So I want to welcome you again to another segment, but for computers, on how to draw, to construct or write down what we are calling as being, a flowchart from a pseudocode. So this is the 2024 paper 2 question 3 ECZ question that said the following program is written in form of a pseudocode. So they told you this program is written in form of a pseudocode. So this is how a pseudocode, appears. If you notice, there's actually start, enter. They want us to enter R, comma S. Then if S is less than R, then we need to display the error S is not valid. Else, we write the formula there. Area is equal to pi multiplied by R multiplied by S there. Then we end if we print, the area in this case, and therefore we are going to stop. Now I want you to notice something, that can give you an eye opener. When they are writing a pseudocode in this case, you notice that, the start and the stop are actually in the same line. The enter there and the print are also going to be in the same line. So print can actually indicate their display, or you can indicate your output. They are also in the same line. Then you can notice the use of, if, then, else, and if. All those are actually capitalized. They can slightly go in, between the enter and the print. So that's the manner in which a pseudocode is actually written. Now let's try to look at the solution to this one. Sorry, allow me, my space is limited, so I just want to utilize, this space that I have. I hope it actually does, work out. So if we look at the solution there, what's the first thing that we are going to do? Well, we need to start the program. So I'm actually going to say, start. But what do we use when we are starting a program? Remember, you need to use the oval shape. So that is what you're going to use, the oval shape there. From there, I'll run down using my flow arrows. I need to enter R and S. What do you use? Remember, we use what we are calling as being a parallelogram. So that is what you use. So you are going to write there, you enter, but what are you entering? You are entering R, comma, S. That's what you're entering. Now there it says if S is less than R, so you have a decision there to make. So what are you going to write there? Well, we need to put up, in this case, a decision box is going to come in there. So what are we going to write in the decision box? Well, you can write and say, is my S less than R? That's the question that you have. So if the answer is yes, print, then we need, if the answer is yes according to that, then we need, if the answer is yes, then we need to print an error message. So you can actually put it also in a parallelogram there. What is the error message? So the error message that we are putting up, so that is actually an error. But what's the error message there? It says S, in this case, is not valid. So it is actually not valid. Of course, if S is not valid, it simply means we need to try something else. So this can actually be returned so that you try actually a different value, because S indeed should not be less than that. But of course, if S is not less than that, then we'll proceed in that direction. So we'll say no in that direction and proceed. What are we going to do if that's okay? If S is not less than R, if the answer is no, it simply means that we can write we can actually get to display the formula. Of course, when you're displaying the formula, like I said, you always put it in a rectangular box. So how do you display a formula? Remember, they gave us, in this case, else. We write this. So we print the formula. The area is equal to, pi multiply. Remember, we use an asterisk and not multiplication, times R again times our S. So that's the formula that we display. Sorry, because of the space, I'll write it in this direction, but it's supposed to go down. So let me just continue it from this side. I'll continue it from this side. So what are we going to write? So once the value of R and S have been entered into this formula, the next thing that you're going to have is that you need to print the formula there. So therefore, you're going to use a parallelogram and simply say, print. What are you printing? It's the solution in this case to this formula, which is the area you're finding. So we'll print our A as we have been taught here. Then the next thing that you're going to do, where the program will come to a stop. So this is the way you can actually go about, by converting a pseudocode that you have been given into what we are calling as being a flow chart. So we have just constructed. Remember, this guy here continues in that direction, so it should be able to go down. It's because of just the space that I had. But let's look at another question that came in the paper one. Well, I've eliminated what appears to be redundant. Sorry for that, but you can check it out in the 2024 paper 1 question number 20B. That's why you can check it. So they gave us a parallelogram, and remember in your paper 1 they are going to start for you. If it is a pseudocode, they are going to start it for you. What you just need is to complete it up. So it says in the space below is an incomplete written pseudocode for calculating the area A of a trapezium. Complete, or that should be complete. So that word should actually be complete, the diagram. So complete the diagram. So they want us to complete the diagram on these two, dashes that they have actually given us, dotted lines that they have given us. So it says start, we enter. What do we enter? That's what they want us to fill in. What's A equal to? That's what they want. The output is A, then the program comes to a stop. Now, because they are talking about finding the area of a trapezium, you need to remember that the area of a trapezium, let me just write it here. The area of a trapezium is simply given by half multiplied by A plus B multiplied by H. In this case, this is the formula that we use for finding areas of a trapezium. So remember, half A is referring to the two parallel sides, the shorter one plus the longer one. Then we multiply whatever we get in there by the height between the two parallel lines. So it's important that you get to know your formulas under mensuration, because some of them you are going to be using as you are going to be applying that. You need a vast formulas in your mind. So in your toolbox it should really be filled up so that you are able to recall that that's the formula. So now, if you notice in this formula, what things do we need to substitute? Well, you need to substitute to know what A is from A to B. You need to know what your AB is, and you also need to know the height in order for you to calculate the area. So therefore, for me to complete this pseudocode, I'll enter. What am I going to enter? Well, you need to enter your A, comma, you need to enter your B, and you also need to enter your H. So these are three quantities that you need to enter in order to calculate, the area. So once I enter this, I need to actually display the formula. So now here, they want you to write the formula. So that formula, but remember how we write it, we don't just write it anyhow. So I can say area, A is equal to, they have started for me, so I can say it to be half. Then I'll say, if I want, I can say multiply by, in this case, A plus B. Remember, the plus does not change. Multiply again by H. So that's the way you can write it. Others might prefer, they may divide this one here. So others may actually write it here. They would have said maybe a 0.5, because 1 divided by 2 is 0.5. Multiply by A plus B multiplied by H. So they could have written it like that. There's no problem with that. So basically, these are the 2 points that they wanted you to get to complete up this pseudocode. So you can see this is the way it is written. It is very simple. I'll give you more examples so that you can actually practice some more past, ECZ questions in my next videos. Thank you so much for watching. See you in my next video.